Hi there, you're welcome back to this channel. So in this section, I'm going to take you through higher order derivatives. We've dealt with partial derivatives and other stuffs in our previous lesson. So if this is the first time you're visiting this channel, kindly subscribe so you visit all those videos. Find all the second order derivatives for this multivariable function here. So in this video, we are treating higher order derivatives of multivariable functions. A multivariable function has more than one variable, right? You know that if I have f of x, the first derivative is what? F prime of x. The second derivative is f prime prime of x. But when I have a multivariable f of xy, the first derivative is going to be partial derivative with respect to what? X, fx, and fy. These are the first derivatives. Now, the second derivatives will be either be fxx, fyy, or fxy, or fyx. Take notes. So, whenever you have a multivariable function, you first differentiate to get your partial derivatives, right? So, this fx and fy, they become two new separate functions. So, if you want to find the second derivative, it's either you differentiate your partial derivative x with respect to x again to get this, or you differentiate your partial derivative with respect to y with respect to y to get this, or the one with x will now go for y to get this, and now with y will go for x to get this. So these are the different possibilities to find your higher derivatives for multivariable functions. So let's get straight to what we have here, the problem, so you understand it very, very well. So solution. Second order. So first of all, let's find fx with respect to x. So with respect to x, this function will give me, see, there is no x here, right? So cos 2y becomes a constant, everything goes away. But there is x here. So the x is standing there alone. So when I differentiate this x, I'm going to get negative 2x. Multiplying the rest of the expression, e to the power 5y. There is no x here. So this is simply equal to negative 2x e to the power 5y. So once I have this, I move to finding fy. There is y here, yes, so I have to differentiate this with respect to y. And what am I getting? This is a cosine. So the 2 will move out as a constant. So you get negative 2 sine 2y. So you should know them from calculus 2, right? Yep. So this, then when I come here, there's y here, okay, but it's attached to the exponential function. So to solve, to differentiate this exponential function, you simply find the derivative of the power, then you multiply by the entire expression. That's all. So differentiating the power with respect to y, I'll get 5. So minus 5 s squared e to the power 5y. Then finally, this gives me what? 6y. This side give me 6y. So the last expression I have here gives me 6y. So I'll get plus 6y. This is fy. Now for the second derivatives, I'm going to start from, this is a new function on its own. So I'll differentiate this function with respect to what? X. So that I'll get fxx. So for fxx, I'm going to differentiate this with respect to x. So I still have x out. When I differentiate x, I'm getting 1. So I'll get negative 2 e to the power 5y. Then I come here, fyy. For fyy, I'm differentiating this with respect to y again. So when I come here, I'm getting sine 2y, okay? So the 2 will come out as a constant. I get negative 4 cos 2y. Then this side is, yes, it's still exponential function. I'll have to differentiate the power and multiply by the rest of the expression. So negative 25. So negative 25 s squared. So negative 25 s squared Then I'll have e to the power 5y. Then differentiating this with respect to y, I'm getting plus 6. The next thing is to find the derivative of this with respect to y, that is fxy. So now I have this, but I'm going to differentiate this expression with respect to y. I simply find the derivative of the power, which is what? 5, and I multiply by the whole expression. So this is 5 by negative 2x e to the power 5y, and that will give me negative 10x e to the power 5y. Then fyx will be equal to, I'm differentiating this expression, this whole expression, with respect to x. Okay, all this expression with respect to x. So with respect to x, my first term will go. Negative 2 sine 2y is to go because it's a constant. So 0. Then with respect to x, I'm going to get negative 10x. Then this is also a constant. So minus 10x e to the power 5y. Then my 6y also turns 0. This 6y turns 0. So my fyx is simply equal to negative 10x e to the power 5y. And this is the end of this video. We've got the second order derivative. So we have this as the first part. Then the second order parts are this, this. Right. Yeah, so thank you for being in this video. Please don't forget to like, you subscribe, then also you share.